Okay, let's do this. Okay. Hey everybody, it's now in the evening. I've done all the things that I needed to do today, and I've spent quite a bit of time on my code. And I think that I got a working solution for part 2. I tested it on the test input and it seems good. Let me move back to the test input here. Let me see. So for part 2, yeah, that matches. So I think I have it solved. For those of you that have no clue what I'm doing, let me put this back into the chat. This is Advent of Code day 17, and I've been having a lot of fun with it. This one was quite difficult. Well, not difficult. The second part was quite difficult, and I managed to do a bunch of cool stuff to solve it. So I think that's pretty cool. Part 1 was building Tetris basically, so that was fun. And let me pull up a secondary monitor just in case. Let me see. Okay, that should be good. Let me check. So basically we wrote Tetris in the first part, and that was fun, and I managed to do that. And then I ran out of time and I had to do stuff with the family, take on groceries, visit friends, etc. So after that, in the evening, after I put the kids to bed, I've done some more coding, and yeah, I basically went down the idea that I had beforehand, and that was to check the command length modulus or times the amount of items to see if that is the part where it starts repeating. But that's not the case, because it first needs to form like a stable ground first. And then I was like, okay, we need to find out how to detect this actually. So what I did was I wrote, and it's very messy and not cleaned up yet, so excuse me for that. What I did was actually, and let's go back to the real input because I want to submit this in a bit. I first started out figuring out, well, okay, we need to find a way to see when the pattern has stabilized. And how can you tell? I started by thinking, okay, you know what? I'll keep track of at which index in the move list, and you know our move list is big, at what index our first block gets its first move, right? So I figured there should be a pattern forming at some point, so at a given moment we should see those numbers recurring. So I started to keep track of them and print them out. And I figured, like, after we've done about half the move list in length, we can start to check indexes. Maybe this can be shorter or whatever. I just figured I'd take an arbitrary number to collect some data, then try to find the indexes, and then we move on to a pattern, etc. So first, let me talk about this find pattern code that I wrote. And I think this one is really interesting. At least I had fun writing it. Basically what it does, it lets you put in an array of ints, and this can be any value actually, just as it's IEnumerable. If it's an int or an array, it's easier because you can do index stuff. So you pass in, or in this one it's an extension function, a repeating range, or not repeating, a range of values. And within that set of values, you try to find a repeating pattern. And I have some options here. I set the min size to 3, so that we need to have a reoccurring pattern of at least 3 in a row for it to be counted as a pattern, and where you want to start searching. And this one should probably be a lot higher, but I was like the smallest sane thing that you can do is probably look for 3, because otherwise can you really speak about a pattern? This could be extended to be restricted to just find continuous patterns. So that you could say, okay, I want to find a pattern that keeps repeating and tell me more info about that. But in this case, it just returns when the pattern starts and how long the pattern is. So what it does, it starts looping it where you tell it to. And then it will try to find out if there is a pattern repeat. So it will start from the index that you are at. It will look ahead, basically. And we start at the min size because that's the first point that we can consider really an actual value. And then we try to find the next time that pattern occurs, right? And if that never happens, distance remains -1 and this part doesn't execute. So in this case, you start at one point and you try to find the next instance of that same value. Basically an index of function. Once it does that, it calculates the distance and it stops this loop. Then, if there is a distance found, right, it will take that and it record, okay, I found a pattern size of 1, because basically that is the first repeat. And we need to have a min repeat value. So what we do is we keep looking ahead until we either catch up to the distance, which means that we've searched the space in which it can repeat, because after that it would be no longer a same pattern but a bigger pattern. It will increment this. This is probably not something that I should do like this because it's easily to miss what happens here. So I increment J here and I add it to the current one, and J is basically the current is 0. So it will check if the point that we started at, right? If the next point, and this one, because it moves on, so it becomes 1, so the point that we're looking at +1, if that's equal to the distance +1. So it will check in parallel with the same distance if the values keep adding up. And as long as that happens, it says, okay, size increases, and once the size matches either the full distance that we've looked ahead, then it will be a repeating pattern that fully repeats in sequence. Or if it's at least larger than the min size, it will report it back. And as you see, I have some comments here about what I could do with this in the future, etc. And maybe have other branches, but yeah. And this one, I just always do console write line so that I can set a breakpoint that's faster than a conditional breakpoint. So this one is pretty cool. And I can show you the thing in action. So let me just put a breakpoint here and run this. Okay, let me pick up the code. So what you can see here is that it ran for a while and then it found a repeating pattern. It started at index 195, it's 345 long before it starts repeating, so it's a very big pattern. Because you know this is only the move indexes for the first shape. So this is a very big pattern because I only looked at part of the data to find it. And basically my next move was to say, okay, let me look at what happens every time piece 0 starts at move, and this is the first of the repeating pattern. So, and that is the next part of this code. So once I established the pattern, let me see, this one was another thing that didn't pan out that I was doing. So what you can see here is skipped height. This is for later, but this just prevents double execution of stuff. Once pattern length, and this is initialized to 0 because there's no pattern. Once there is a pattern length found, check if we're at the first item of our shapes. No, sorry, check if, because that already is checked up here, the block index shape count. Check if we're at the move, which is the first move out of that pattern sequence. That is the check that we do. And once that happens, it will actually do some calculations. It will keep track of how many items are added since the last time, etc, etc, etc. And also it will save a snapshot of the grid that it drew since the previous iteration, which is this iteration grid. Okay, so what we do here, let me set a breakpoint inside here and show you. Okay, this is the first time now after that we found the pattern. Confusion set. I like your funny words, Magic Man. Yeah, sorry, I'm just really excited that I got this figured out, because this is something that I've never done before and it took a lot of fiddling and trying, and so there's all sorts of concepts that I managed to pull together, which is really cool, and I just get happy from creating stuff like this. So yeah, if I'm a bit hyped and excited, that's why. So yeah, basically it will keep track here, so it will tell you how much it gained since the previous time, and since this is the first time that it ran, this isn't really representative because we don't have something to compare it to. So right, this first time it will just dump this grid and it will build a very large grid, right? And you can see here iterations grid equals previous grid, which is null, that is false. So now it will keep track of that one, and I think the next one it will also be wrong, because the first time this was built up, we had a too big backsplash or back search. So it will have a grid that's not really just the iteration part. But the next time we get here, and let me hit this, now you can see the new count is 47,890, which means that we have 2,728 items gained. That's more reasonable. So now it will spit out some info about that. So you can see here at this index, that block index, move index, and this is the one that we found in our repeating grid. It tells you the current height, how much it is gained since the last time, etc. So now it will say, okay, this is just for drawing the grid. It will get the iterations grid, and now it will compare them. And what do you know? It's exactly the same as the previous time. So this is the third time that we actually could have detected this, but it doesn't matter, right? It finds it all on its own and it works. So basically what it does now is to check, okay, now that we found a repeating pattern, we can now skip the entire search space that we need to do. So we try to find out, and you can see that here, jump IX is the amount of blocks that we processed in one of those loops. So it means that we can skip in multiples of 1725, and it will give us 2728 in height. So that's also what it spits out here. We can gain this much height every this much blocks we process. We needed this many blocks processed before we got to this stable state, and we could have detected this earlier if I let this pattern start, search start earlier, etc. It all doesn't matter. There can be lots of tweaks to this, but it runs in milliseconds, so who cares? So then it moves on, and here it tells you how much cycles it can skip. And this will tell you at which block height it will resume, because we will fold all that stuff into this skipped height value. So since we've detected all of that, we need to do one less than we count. So we take the amount of cycles, the amount of stuff that we need to skip. That means that this is the value that we add to everything that we've done, and then we process just the final tail of stuff that we can't completely skip, because it's not fitting entirely inside that repeating pattern. So yeah, if I just let it run now, it will say, okay, we can resume at this block height to process the last 2350 cycles. So it says this is the answer, and now after a lot of time, let me see if this is accepted. Woo! Part 2 done. Nice. I really liked this one, and yeah, it's always cool to get to the end in a good way. I spent way too much time on this though, but I've had so much fun building this, and I've learned a lot, and I really like that find pattern thing, etc. So I will probably play a bit more with it, and maybe just start to start right away with pattern finding and don't wait until we've collected like thousands of moves. But yeah, it's been fun. So the only thing that I still have to do now is rewrite part 2 of yesterday to do that in parallel, but yeah, it's already late. So I might do that. I still might do that in a bit off stream, just so that I can relax a bit more. But yeah, I'll find some time to do that in the next few days. But I must say, I've been having a lot of fun this year with all the challenges, and yeah, it's been nice having people check out what I do and enjoy the things that I do. So, not a very long stream, but yeah, I hope you liked it, and I'll make a post to Reddit with a lot of the code, and I'll clean it up a bit more when I have some time and add some timestamps to the videos. And yeah, that's it. Oh yeah, the only thing that I wanted to tell you is I sometimes search for my own videos just to check something back, and I noticed that when I search for like Advent of Code Day 16, my video doesn't even show up. So if you want to see more of this stuff, try to hit the subscribe button so that you at least get shown this, because the search will not always show my videos. So yeah, thank you and have a good night. See you tomorrow.